I'm going to talk to you guys about how to solve addition equations, and these are equations where there is a variable and there is a plus sign and you're trying to figure out what x is equal to. So I'm going to start off with the equation x plus 3 equals 5. Now there is a website, and you will have to look at the top of this screen to see what the website is, and I can actually give it to you in class. But it's a great website where you have what's called virtual manipulatives. And so you can play with tiles in a balance beam online without actually having to have the items. So I'm going to show you guys how to use this with this equation. And we're going to start off with x plus 3 equals 5. So the way I'm going to model it, remember on a balance beam, okay, on a balance beam you have your left side and you have your right side, and both sides need to be equal. So this is x plus 1, 2, 3 on the left, and then we have our equal signs in the middle, and then on the right we're going to put 5. 1, 2, 3, 4, it's frozen, and 5. And so it's balanced because one side isn't dipping down while the other side is up. So to figure out what x is, I have to take some cubes off of here, but whatever I take off on the left, I have to take off on the right. So I can take 3 cubes off of here on the left, so now I'm going to take 3 cubes off on the right. So that leaves me with x is equal to 2. So the way we're going to show that, remember, you're going to show how to solve these equations the same way every single time. Even though we all know x is 2, I still want to see the work every single time. If I don't see the work, it's wrong, even if you have the right answer. And I'm not doing that because I'm trying to be picky. I'm doing that because I'm trying to get you in habit of doing it this way. That way when you're doing your math through the rest of middle school, high school, college, all algebra problems are solved this basic same way, where you're doing things to both sides of the equation. So this is how I want you to show your work for these problems. Kind of like the balance beam, you're going to split it into 2 parts. You've got your left side and your right side that need to be equal to each other. So to solve for the variable, I need to get rid of this plus 3. Well, to do that, I'm going to subtract 3. But whatever I subtract on the left, I have to show on the right, or do the same thing on the right. My plus 3 minus 3 cancels out, so I'm left with x is equal to 5 minus 3 is 2. So the answer is x equals 2. And I know I'm right because 2 plus 3 is equal to 5. Okay? Alright. The next one I'm going to show you guys is x plus 7 equals 8. Again, we have 2 sides of the equal sign, or 2 sides of the equation, the left side and the right side. And I want to get the x by itself, so I'm going to subtract 7 on the left, but I'm also going to subtract 7 on the right. When I do that, my plus 7 minus 7 cancels out, so I'm left with x is equal to 8 minus 7, which is 1. And I know I'm right because 1 plus 7 is equal to 8. Alright, the third one I'm going to do is 3 is equal to x plus 1. Don't let it confuse you if the variable's on the right side. It doesn't matter which side the variable is on. It can be either way. Okay, so again, I'm going to split my equation into 2 parts. I'm going to subtract 1 over here, subtract 1 on the left. This cancels out, so I'm left with x is equal to 3 minus 1, which is 2. Make sure you always put x is equal to the variable, or whatever variable x is equal to the number, or whatever variable you're using. Don't just say the answer is 2. Say x is equal to 2. And I think it's a good habit to circle your answer just so that your answer stands out. And then you can go back and check your work. 3 is equal to 2 plus 1, and you know you're right. Okay? The last one I'm going to show you is with decimals. And you don't do it any different way just because there's a decimal there, okay? Again, we're going to split our equation into 2 parts. On this one, to get the c by itself, we're going to have to subtract 2. So I'm going to subtract 2 over here, but remember 2 is the same thing as 2.0, and that's important because if you put the 2 over here, then you're subtracting the ones place from the tens place, and we don't want to do that. So doing it this way and even filling in zeros as placeholders helps make sure that we're subtracting tenths and we're subtracting ones and then the tens place. So this cancels out. I'm left with c is equal to, and I have a 5, 5, 2. So the answer is 25.5. C is equal to 25.5. And I know I'm right because 25.5 plus 2 wholes, or 2 ones, is 27.5.